One of the most interesting topics within sequences and series is the binomial expansion. I love this topic because it touches on combinations, and it goes into many other subjects like biology, statistics, physics, and chemistry, and so forth. So let us have a look at where it comes from, where the binomial numbers come from. So it has to be two different events. I've got two events here, A and B. And let's say I'm trying to pick out A and B, and I do this 3 times. Okay, so I've got A and I've got B, and I'm trying to do this 3 times. And then I'll show you what that actually looks like. So how many different combinations are there? Well, if I'm trying to get three letters here, and I've got 2 of them, I've got 2 events, that's 2 to the power of 3, that's a total of 8 different combinations. Okay, you can combine A and B 8 different ways such that you have three of the letters. So let me show you what this means. So there's 2 and a total of 8. 8 divided by 2 is 4. So A, 1, 2, 3, 4. 1, 2, 3, 4. And then 4 divided by 2 is 2. So 1, 2, 1, 2, 1, 2, 1, 2. 2 divided by 2 is 1, 1, 1, 1, 1, 1, 1, 1, 1. So these are all the different combinations possible. 8 different combinations possible of arranging A and B. Now, if the order matters, yes, you can arrange them, this way. This shows that, well, if you are listing them like this, it means that the order does matter. However, what this means is that there is only one of these, and there's only one of these, right? And the scenario where there are 2 A's and a B, 2 A's and a B, 2 A's and a B, there are 3 of them. There's this, and there's this. Equally, there are 3 scenarios where there's 2 B's and an A, which is this, and this. So there is one scenario where there's A, 3 scenarios where there are 2 A's and a B. There are 3 scenarios where there's 1 A and 2 B's, and there's one scenario with B. Now, this is exactly the expansion of A plus B to the power of 3. And remember, if the order did matter, then a way of getting AAB is only one. There's only one way of getting A, and then a B. But if you only care about 2 A's and a B, there are 3 different ways of doing that. So, it depends on the scenario, it depends on the question, whether the order matters or not. But here in binomial expansion, when we're looking at these numbers, no, it does not. Another thing to think about is that A and B could be anything, really. And the fact that this is symmetrical, like you get 1 here, 1 here, 3 here, 3 here, is also important. Now, if you did this for numbers such as A plus B to the power of 2, well, starting from 0, really. The power of 0 is just 1. To the power of 1 is just A plus B, which is 1 and 1. To the power of 2, well, we know that's just expanding in quadratic, right? It's just A squared, which is just 1 AA plus 2AB, which is an A and a B and a B and an A, plus 1B squared. So you see these numbers? These are the numbers that make up the Pascal triangle. And another way to get them is this. So you start with 1, 1, 1, 1, 2, 1. So this 2 here is a sum of 1 and 1 here. Okay? 1 plus 2 is 3, 2 plus 1 is 3, 1. All right, you see it? 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then obviously it has to end with a 1. Let's do the last line, or the last line in this example, because I don't want to write it all the way to infinity. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then 1. So this tells me that this is a plus b to the power of 0. This is a plus b to the power of 1, to the power of 2, to the power of 3, and so forth. And so forth. Now, again, remember the symmetry that we talked about earlier, right? If you go down about this point here, this side of the triangle looks the same as this side of the triangle. And that's important because it just means that all you need to know is the first half of the numbers, right? So that's one pattern that could be useful later on. Again, since we are studying sequences and series, is an important thing to note. What else can we say about this Pascal's triangle? The fact that the sum of the numbers in each row. So here's 1, here it is 2, here is 2 plus 1 plus 1 is 4, here it's 8. What about here? Well, we've got 10, 14, 16. Right? What does this look like? It looks like a geometric, these look like geometric numbers, a sequence, whereas 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, etc. So, in fact, the sum of each row is 2 to the power of n, where n is the number of times that we're picking out, for example. Okay, so another thing that we can note about this triangle is the sequence of numbers in these diagonals, let's call them. And remember, they're symmetrical. So I'm just looking at them from one direction. So all these numbers are always going to be 1. Right? So it's just 1. These numbers here just go 1, 2, 3, 4. So in fact, they just n because it is the number that is the number that is the power. It's the number of events, the number of times. The number of times we let's say throw the dice. So here, that's just n. So, and you can see that we went from n to the power of 0. This is n to the power of 1. The next term is going to be a quadratic term. And a quick exercise for you is to find what the nth term is for this sequence of numbers. 1, 3, 6, 10. All I can tell you is that it's of the order of n squared. But let me know in the comment what you think it is. And therefore, this would be n cubed, and so on and so forth. It will be good for you to practice what the formula, the nth term is for this sequence. Nice. So we have noted different things about this triangle. But another thing is the actual term, right? It's the actual coefficient, the actual number here. How do we write the term for it? In general, the general expression for that term. Well, if you think about it, here, this is the number of ways of choosing, right? So if in our example where we had three times, this is the number of choosing such that there is no B, but all of them are A's, right? And the next number is the number of ways of choosing 2 A's and 1 B. The number of ways of choosing 2 B's and 1 A. The number of ways of choosing 3 B's and no A. So this is where the term is introduced, N choose R, which is also written as NR. Like this. And this basically says, if in this scenario, let's say a scenario where we have A plus B to the power of 3, that is a 3 choose something, right? So let's say we have an example, 3 choose 0. So this says the number of ways of choosing 0 let's say A's, 0, because it's symmetrical, so it doesn't really matter, but number of ways of choosing 0 A's when we're doing it 3 times, right? That's 1. And in fact, whenever this number is 0 or this number is 3, because it's symmetrical, so we're talking about this part of the triangle, the number of ways of choosing 3 A's and 0 B, or the number of ways of choosing 3 B's and 0 A's, and this number are always going to be equal. So n choose 0 equals to n choose n. So n0 equals to nn. And this is always true, by the way. And you can always write this down as to be true. So I've explained what n choose r means, right? And in this situation, another example, 3 choose 1. So this is a number of ways of choosing 1a, and so obviously if you're choosing 1a, the other 2 have to be b's. So 2 b's and an a. We know that that's 3. But to be honest, it's the same thing as choosing 2 a's and a b, which is also 3. So this is also equals in this scenario, right? In this scenario, because that's where the line of symmetry goes through. Such that 3 is the same as 3, but it's not always that n choose 1 and n choose 2 are equal. I hope that makes sense. So yeah, last but not least, let us have a look at, well, just what we can say is that the sum, when we know that the sum of these rows is 2 to the power n, so we can actually say then, if we know how to write down an expression for each of these terms, which is n choose r, that if I sum n choose r, starting from r equals to 0, which is the first term, which is always 1, starting from there, all the way to n, because it goes up to n, right? This has to be equal to 2 to the power of n. And this is a formula that, well, now that you know, you don't have to remember it. You can just always just write it down because you know it. It's not something you have to cram, but you can encounter this in other topics that you have to show. If you have to prove something, you can always say that this is always true. So what is n choose r then? How else can we define it? Well, something you have to remember is that it is written as n factorial over n minus r factorial times r factorial. What is a factorial? Factorial is just, if I say, well, 0's factorial is defined as 1. 1 factorial is defined as 1, well, just 1 times 1 really. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. Right? And then 4 factorial is 4 times 3 times 2 times 1. And that is how it is written. So you can use this to expand and find other formulas.